Welcome back to the Innovation by Design podcast, where we explore how design thinking drives innovation across the architecture, engineering, and construction industries. I'm Evan Troxel, joined by my co-host Candace Kitchen, and Candace is going to introduce our guest for this episode.
Thanks so much, Evan. Good to see you all. Today we have Ming Tang, a professor at the University of Cincinnati and director of the XR Lab, where he explores the intersection of architecture, digital technology, and spatial computing. A registered architect and award-winning researcher, his work focuses on how immersive technologies like XR, AI, and digital twins are transforming how we design, build, and learn. So, Ming, would you mind starting out just kind of telling us a little bit about yourself, about your story?
Sure. Great pleasure to be here today. Thanks for the invitation. I'm an architect, but also I'm an educator. I was a student in Tsinghua University back to 1992. That's where I got my architecture design education. And I moved to the United States in the year 2000. I was a student in Michigan State University. And there, very interestingly, I'm not studying architecture. After 8 years of study architecture in China, I switched my major to interactive media. So in Michigan State, I stayed about 2-3 years, work with Dr. Frank Bioka, who is the director in the Mind Lab, doing a lot of really cool stuff related to VR. After I graduate, I moved to Savannah College Art and Design. I was there as the faculty teaching architecture for 7 years. And then I moved here to Cincinnati. Now I'm a faculty professor in architecture interior design program at the University of Cincinnati. Meanwhile, I'm directing a lab which is called Extended Reality Lab, XR Lab. We do a lot of projects in the intersection of architecture with the digital media and game design.
VR, virtual reality, AR, augmented reality, I think these are becoming much more mainstream, recognizable terms. And then there's XR, which is extended reality. And to me, it's kind of it's a mix, but an augmentation even of virtual reality and augmented reality. And I would love for you to kind of define extended reality, the whole XR terminology, so that the audience who's maybe never heard of it before gets kind of a baseline understanding, and then we can jump deeper into it after that.
Yeah, of course. In general, XR can be divided into VR, virtual reality, AR, augmented reality, and MR, mixed reality, these three different categories. I think VR, we all understand, is like a black box, right? Where when you wear this headset, for example, this Meta, you are basically in a black box. So everything you see is 100% digital. You are kind of cutting off from the reality. So that's VR. For the AR, augmented reality, I think a very good example is a mobile phone app, Pokemon Go. So where you can overlay the reality with a small screen, you can see the virtual objects overlaid on top of your screen, right? So you see both at the same time. Mixed reality is a little bit different. So for example, with the Meta headset, it has the front cameras. I think the same technology you can see from the Apple Vision Pro. It's using a front camera to capture the reality and then render this video directly into your eye. So it almost feels like you are seeing through the headset, right? Feels like the headset is transparent. So the mixed reality definitely gives you a lot of other controls. For example, you can see your hand, you can have virtual objects, you can interact, you can grab, you can, cutting sections for virtual objects. So it just gives you a whole new level of interaction in MR. But again, in a kind of practice, there's a lot of overlapping between these three. So sometimes people don't really care too much about clear boundaries between these two. Some apps can do both in some case. So my lab is really kind of very heavy with VR. A lot of projects we have done is virtual reality. But in recent years, with the front cameras getting better and better, full color, high resolution, we're doing more about MR projects.
that there's a place for each one of these technologies, right? Virtual reality and being completely cut off from your immediate environment in many ways, visually for sure.
Yes.
It tricks your brain to make you feel like you actually are in a different place because the current context doesn't apply, right? And so in architecture, when a client puts the goggles on, they kind of are transported to a place now that is a future version of the building they're going to be sitting in, right? So it's a digital representation. And I think what's so interesting about VR and AR and MR and XR and, you know, all the realities is it really engages the senses in a way that cannot be done in a 2D environment, which could be a screen, it could be paper, it could be renderings, like, and that immersive environment really does engage the senses. I'm sure that had to really entice you early on. I'm curious if you could explain your early engagements with VR, because that was kind of what kicked all of this off. Did that really excite you back then? And because it's been around for a while, right?
Yes, absolutely. Well, this will have to dial the time back to 1990s. I'm very old. 1990s. When I was
you
a
and
student.
me both, Ming.
Okay.
Candace is the spring chicken here. Yes.
I'm a 90s baby still.
Okay.
All right, let's talk about 90s. So 90s, I think that's the first generation of AutoCAD. There's just a begin the transition from DOS to Windows operating system. And I think at that point of time, doing drawings with AutoCAD, the first time I learned you can undo, that is really amazing. Because what we learned in the school is watercolor, drawing, sketch. It's very difficult to undo anything.
You were committed, right? With especially with ink on Mylar back in
Yes.
those days, it was like when you put a line down, you felt like it was permanent, because in many ways it was.
That's the road you want to go down. It's very difficult to modify anything in the watercolor or ink. So when we use AutoCAD, I think we just began to realize it's capable to do 3D as well. This is actually back to 1995. So I believe one of my capstone project, one of the first few students actually built a 3D model in AutoCAD and then print the perspectives and show that in the final presentation. I'm really grateful the professor not, challenged me about my skills of, doing rendering, because at that point, everything is very line work based. It's very flat grid shapes. But they are happy with it. So that is the beginning of my interest on computer renderings. And then there's the 3ds Max, right? This first 3D rendering program. You are able to set up lighting, material. You are able to render photorealistic renderings. I think at that point of time, I use a very old machine, which can take the entire night, just render this tiny, 400 by 300 pixel resolution image. So you click the render button, you go to sleep. Next morning, you wake up, you got this tiny rendering, and everybody is super excited about this. I think that's the time I start to really, dive into this computer digital type of renderings. When I was in graduate school, I studied with Professor Zhu Wenyi, who is really an excellent professor faculty. He actually introduced me, we can use a digitized way to understand the city, the urban scale. So we actually digitized the map of Beijing, lay out all the streets, and then I'm able to use layers in AutoCAD to kind of find the patterns of the streets. So that's, in 1999. And then when I moved to United States, work with Dr. Frank Bielka. He has a lab, has VR equipment. If you recall back to the beginning of 2000, the VR is not commercialized as the way it has today. So it's very, very expensive. Only a few universities of the government is able to have this facility. So I'm very lucky to be able to work with Dr. Frank Bielka. He actually hired me as a student. My first job is just create a 3D model of a building, something like that. So I have access to VR. It's just really magical the first time you are in an immersive environment. As you said, Evan, you are cutting off from the surrounding. You're totally immersed into a different world. That is really amazing experience.
Absolutely. And then you start to learn about there aren't actually physics in there except for your own body still being in physical space, but you can poke your head through walls, and there's so many things that I've sat with many clients in the architecture office putting on a headset and having so much fun because they aren't bound by the limitations of the real world. And so they want to go to another room and they just pop through the wall into the next room. And it's really fun because it's like you actually get to see people, grown adults, start to play in 3D space. And I feel like that's a little bit of what the architectural design process is for those clients to experience. And that's why it can also be so impactful to be a part of the process with them at these early stages, right before the physical building is built, to experience it spatially, but also to have fun doing it and to really feel like what those spaces are going to be like in the future. How big are they going to feel? Again, this is something that's completely lost in the translation of it just being in an image on a computer screen. It's hard for a normal person, right, to get the sense of how big a space is or how small a space is or what the natural light is like in that space at any time of the day. And these are the kinds of things that VR technology can afford us in the way that we communicate to clients. And it's like once you see it as an architect, you can't remember what it's like to not have that. It's kind of one of those things where I imagine just was incredibly exciting because then you see so much potential to give people these experiences, and you're basically solidifying in their mind what the space is actually going to be like in a very real way. It's not just a representation. I can't tell you how many times I've had a client where you show them an image and then we build a building and they're like, wow, I had no idea it was going to be like this. They say that all the time. And so this immersive 3D really it's a game changer in many ways, especially from the inclusion of that person in the design process early on before the building is actually built.
Yes, absolutely. I think we human learning environment or perceive environment through interactions. From million years of evolution, right? We use our body to learn the space. And quite often you have to interact with the space in a kind of four-dimensional way, three-dimensional time. So if you imagine we are walking through a space, right, a corridor, or if you climb stairs, all the sensory input is reinforce that spatial experience, and we learn from that process. A 2D or even as fly-through animations never able to deliver this kind of interactions. So in VR, you are able to do this, all the virtual navigation through the virtual space, and you learn in a much, much deeper way. I'm also always thinking like human behavior in the virtual space compared to the physical space. There's a lot of study in the psychology to compare these two. So for example, back to, when I was a student there, I read the book from Dr. Bioka. The title of the book is called Communication in the Age of Virtual Reality. The book was written in 1990s. I think there's a lot of really interesting points. One of them is about our perception and our behavior in the virtual space compared to the physical space. One good example is actually using painting as a case. We as humans is always trying to reconstruct the physical world, right, with some media. So you can see this in the traditional painting, in the film, in the sculpture, right, in the photography. We always have our own version, want to recreate this world. So he believed this is like a foundation of the tendency or the motivations why we do this. Create a 3D model, create a metaverse, create a game world, right? Like format. Why people do this. And then on top of this layer, he argued we as humans always want to have a freedom away from the limitation of the physical world. So as you said, the gravities, right, the collisions. In the real world, you are not able to overlapping with another objects, right? Because we all have our kind of physical boundaries. But in VR, you can immerse yourself into a wall, right? You don't really need a chair. You can fly. So he believed all of these actions, this experience will lift us from the constraint, the limitation of our physical body, and then you can achieve this higher level of consciousness, kind of the ultimate freedom, or you can call this supernature type of abilities. I think that is really fascinating. There's a lot of VR app is actually pushing that boundaries. It's not just represent a virtual world, but create this kind of fictional world, allow you to do meditations. There's one project we did in a school with a student is doing a simulation of black hole. Is the process, the space gonna warp, deform when you are, dragged into this gravitational field. You're gonna experience a process called spaghettization or noodleization, right? Because everything will be stretched very long based on the gravity. I just totally changed the reality, and you can feel that kind of weirdness in the virtual space. I think that is really fascinating.
That's very fascinating. And I love this idea of almost like unlocking creativity. We all have creativity within us, but it's beyond that. And even further, you get to see more and experience more, but it also helps on the other side of, hey, you might figure out this doesn't work here. This doesn't work there. So, are you finding that you're coming across where maybe you're saving money because you're identifying problems earlier in the project?
Yes, I think we call this scenario as DICE, D-I-C-E, is when the digital technology, especially VR, is appropriate to save us the money, the budget, or the efficiency. DICE stands for dangerous, impossible, counterproductive, and expensive. So these are the scenarios you want to actually create a digital version of the prototype and do tests. Right? I think dangerous is very easy to understand. For example, egress. If you want to simulate how building perform in the case of mass shooting or fire, you can actually create this virtual building. We actually did this in our lab building in UC. We set up fire, we set up smoke, nobody complained. And then we allow all the students where we are to running through the building, right, in a virtual building. And then we can actually record their paths. So over 50 times, you can start to see the patterns. Most people will die in this corridor because there is a dead end, right? So in VR, you can actually test in this very dangerous situation. That's the value of it. Impossible is very easy to understand is, like black hole. We are not really able to experience that, right? Counterproductive means if the visualization or simulation is actually trigger people's anxieties or cutting down their work time, this is counterproductive. In that case, you probably want to think about this physical training can be, migrate into the virtual training. And the last one is expensive. I think a lot of training, for example, like driving simulation, flight simulation, yes, you can train in analog, right? But it will be super expensive. It will crash the vehicle. So with expensive, training process, VR definitely give you the efficiencies. Financially, it makes sense. So these are the scenarios called DICE. Will be, very good values you can bring. If you understand the cost of the real activities.
You immediately sparked my interest with that because I'm in the door and hardware industry with fire and smoke rated doors. So you're talking about the egress of it all and going through the simulation of it, and you can really see the path that people are taking, and that's incredible. That kind of data is really just invaluable.
Yeah, it's also, I want to add on, it's pretty interesting. As I said, the human behavior in VR and reality sometimes is not exactly the same, right? So in the egress simulation, we find a very interesting result. because you don't really sense your body in VR. Well, you can see a virtual body, but it's not physical, right? So I can see people are able to quickly going through very narrow gaps, right? Because there's no collisions.
Right.
And also I see people became very brave. They are able to jump over. I don't know. I think in the reality, you will be very hesitant to do that actions. But in simulation, we see a lot of jump, jump over the stairs, cross the wall, cross the window. I think this is a pretty interesting, if you compare the physical and the virtual and how people behave a little bit differently in the different settings.
It's a lot more like a video game in that sense, right? It's like you'll do things that you normally can't do because you can do them in that environment, right? And so it is a little bit harder to measure actual human behavior when the same rules can't apply because of the nature of the environment that you're in. Yeah,
absolutely. Yeah, but also I think there is a argument is about fidelity. Is if the environmental fidelity is high enough, if our eye is not able to tell the difference between the reality and the virtual. In that case, you can say maybe the behavior is very close to the reality. There's another layer is called emotional fidelity. It's not just about how real, right, the space is rendered, but also the emotion it will impact us. I think for architecture, this is super interesting because a lot of buildings you going through is not neutral. You are able to see the lighting, the material, the spatial, right, the ratios of the space. This will give you a different emotional impact. As an architect, I'm super interested about the measurement people's emotion in this virtual space. Either through some sensors, like device you can measure heartbeat, sweating, or EEG, right, about your brainwave. You can also allow people to do some kind of questionnaire at the end. So they can have, let's say, 20 questions. They can say, yes, I feel stressed here. I feel happy there. So there are some ways you can collect this data and then see if the emotional fidelity has been achieved.
You mentioned a couple of the kind of main headset makers today, Apple and Meta, right? Yes. And kind of at two ends of a price spectrum, maybe, but still, I think overall, based on what the possibilities are that they can do, relatively inexpensive. Even though people might push back against me on the Apple one being about $3,500, but people spend $3,500 on computers all the time. So I don't really think, in the grand scheme of things, it's not that expensive for what you could possibly use it for, because it's not limited to just one thing. And one of the things you're talking about now, and you mentioned earlier, was like this idea of meditation as an example in these spaces. And because a completely neutral or tranquil environment can actually be achieved in that, I think that's so interesting, right? Because you could live in the 35th floor of a high-rise in New York City with sirens and traffic, and then you could put this on and actually be transported. You basically are tricking your mind, your body, into thinking that you are in a completely different, tranquil space, not just because of the visual aspect of it, but also because of the auditory aspect of it, right? It's because the immersive environment can also include sound. And of course, this can be taken more levels, right? I've gone to The Void, which was a I don't know if they're still around, but there was one in Las Vegas, there was one in LA, where you could be basically fully immersed into a fully digital environment. You wear a vest that has haptic feedback, so and you would be in a room where they would blast heat at you. So when there was some rocket taking off, you would feel the heat from it. And so there's ways to engage more of these senses in these kinds of environments. I mean, you're more limited at home than you are by going to a place like The Void, right? But it's really incredible to basically, like we've been talking about the whole time, fully take you to another place and engage a completely different set of senses or achieve a completely different goal than you can when you're in that space that you're in without that technology. Or it would be incredibly expensive or difficult to do so. And rather than build all that out, you can just go into this headset. And I'm just curious when it comes to your students. You talked about UC, University of Cincinnati. What do they think when they see the kind of potential that this could unlock, maybe as an area of study, maybe as a future career? What are they really excited about? Because they're experiencing it, and then they're going through curriculum that's helping them develop those skills. And then I'm really curious where they take that and what they're excited about achieving in the real world.
Oh yeah, absolutely. I think when I was a student, when you graduate, there's multiple paths. You can have career. Work in a large architecture firm. Usually they have some people specialized with rendering, right, with visualizations.
Mm-hmm.
So they are really good at with modeling, lighting, material. They are able to output videos, seal the deal with client. Right? That is a specialized, usually in the large firms. In a smaller firm, they basically do everything from sketch, floor plan, construction document to the visualization. I would argue in this, today with the firm, they always have someone really interested about visualization. I think in the back to 90s, this is very popular. You can outsource this to a specialized small firm to do all the renderings. But I think today most of the firms has this in-house. So have people really specialize with visualization. They are able to deliver the design concept very clearly through digital media. And with a student, if they graduate with the skills, know how to push their design into VR, this is the plus. They will be very competitive in the market, right? Because they are able to communicate to the clients who don't understand the sections and using this new technology. I think the students are getting very excited about these opportunities. And also back to your earlier point about the price, like Meta HMD head-mount displays only $500. It's very, very affordable, right? For average gamers, you can afford. I wonder if you have been to the Sphere in Las Vegas.
Yes.
Yes.
Right. That is ultimate expensive way of immersiveness.
But it's a group setting.
Yes.
It's incredible.
You got this multi-sensory input, right? Sound, acoustic. You probably
the air
got some
cannons, the
right,
blasting
blow the
air at you.
wind.
Right.
Yeah, I was there. I think it's a greeting card from the Earth. That is a movie I watched with my daughter. It's really amazing. There are some mechanical thing under the chair.
Yes.
Will vibrate. It's really amazing experience. And I would say that large spherical screen does deliver immersiveness, right? But in a very expensive way. You can also think about any large screen like IMAX theater. You can have that immersiveness as well because the screen is large enough, it's covered all your field of view. So HMD, head-mounted display, is really the much cheaper, more affordable way. You can get 360 degrees, not just about, field of view. It's entire view. It's all covered. So I think it's super powerful. I'm also very optimistic on this technology is we as human, we don't really need to see super high resolutions. If you really study the human field of view, the only high resolution is around the center of your view. All your peripheral vision is a little bit blurry, right? If you feel now, it's very blurry here.
Yeah, it kind of has to be, right? Because it helps you focus on the things that are right there in front of you, and there's still information in the periphery, but it doesn't need to be in focus like what you're talking about.
Yes. So if you're really interested about something, you will tilt your head or move your eyeball. Right. So this is the thing, I think, for the computer renderings with a head-mount display, they are already able to track your eye movement and able to render the higher resolution in the center of your field and the lower resolution in the peripheral. So it's very, very close to the real human perception. And this has been approved with a lot of eye tracking studies. So I'm super optimistic. I think this technology is matured, as maybe could be cheaper, and also the frame rate, right, is very high. You don't really feel the latency when you are in the VR. It's also became very, very lightweight and wearable. So I think that is a trend going to continue going in the next few years, and eventually, I think we probably have a contact lens type of VR So you are not feel the weight at all. I think that will be the super exciting future.
Yeah, I couldn't agree more. I think it's definitely going to become more accessible in many different ways as time goes on. It got me to thinking a little bit, though, about perhaps even the beginning, the difficulty level of creating these spaces. And I'm sure it's gotten easier over time, and you can probably have, some standards now set up. But, can you speak to how it's gotten easier to use? So, I mean, for someone like myself, it's less scary.
All right. I guess your question is how you can create your own virtual space, right? Not just play a VR game. I think as designers, this is universal for anyone interested about this kind of spatial data. You can use traditional 3D modeling program. Like me, I'm old-fashioned, so 3ds Max, but now my Blender. You can do parametric design, you can do generative AI, create 3D forms, whatever way you want to do. And then you can stream these 3D forms into VR through game engines. Right? So today we use Unity and Unreal. These are the two primary game engines. Unreal is more, towards a AAA game. Unity is very friendly, beginners. Right? So once you understand how to assemble a virtual scenario using 3D model and how to create interactions such as grabbing objects or cutting objects, right? Or, spawn some zombies. You can create this kind of virtual space. And then it's very easy. You can package your game or virtual scenario and make it available for everyone who has this VR headset. So that is the whole flow. Without user group, this will be expensive game, right? But with everybody able to afford the VR headset, you can put this app in a app store. You can make profit. So I think for students realize its potential, this will be huge. They don't have to think about, hey, I just want to design visualization for a single client who want to invest money to build this building. You can actually open up this entire virtual world as a product. And every single person who has VR headset is able to access your scenario. That is just super exciting.
There's so many questions that I could maybe take us in the direction of, but I think one of the things I'm interested in from a listener's standpoint is there's, I think, for a long time been some things holding people back from trying this technology. And you mentioned resolution earlier, and I think you put it very practically. It's like the resolution is actually not an issue, right? The resolution, it's interesting because you could be in what I would consider a low resolution model, and it's totally fine. Like you fill in the details. It's like looking at an abstract or a cubist painting, and you can see what's there without it being explicitly pixel perfect laid out, and the lighting. It doesn't all have to be absolutely perfect, but there are some other things that actually do matter, and I'm sure people have heard from others, oh my gosh, when I put those things on, I got nausea, or things like that. And so that's kind of the direction I wanted to go in. Was there's been myths that have built up over time that technology has solved along the way. Computers have gotten better, faster, stronger. The computation is now happening in the goggles, where maybe before you had to have a wire that connected to a real beefy computer. We used to have these other peripherals in the room, these light towers doing all kinds of things. But now again, like because of the cameras integrated into the goggles, it's basically put it all into one system right on you. Can you talk about what some of those things are, and people who tried it before and were turned off by it might be interested in trying it again now because so much has actually changed in that space?
Yeah, you touch a very important point about the reality and the virtual. In VR, you are basically have these two screen, one for each eye, just in front of your eyeball, right? Mm-hmm. They are rendering, high resolution or low resolution, depends on which content you are looking. So over time, our eye does not really get used to this situation because you have the screen right here.
Mm-hmm.
I think there are statistics about 30% of population will have motion sickness in VR, which is very high.
Mm-hmm.
And also based on our experience, when we design the VR experience, we always want to make that no longer than 15 minutes. And after 15 minutes, you want to take it out, take a break. This is very crucial. For example, when we design a training program for a local hospital, they want to create this virtual hospital, virtual patient. Is a hospital deal with patient with mental issues. Right? They have aggressive behavior. So we have this VR. You are able to act as a staff member or nurse, and you have to deal with people who has aggression towards you. And we have to break down this whole training into multiple sections, and each section no longer than 15 minutes. And also we will do a screen at the beginning just to check if you are very sensitive for motion sickness. If you are, this VR training is not suitable for this type of motion sickness population. And also people with glasses. I think this is actually getting better because sometimes I think the lens can be actually built into VR, so you can dial and adjust. But the motion sickness, the 30% is still there. We want to be very careful not to trigger this. Another really important point is about the disconnection of the sensory input. One of the primary reasons you see people get motion sick is what they see and what their body feel is disconnected. I can give you one example. I wonder if you have ever standing on the beach when the ocean retreat and you look down the wave, you feels like you are moving because the water is flowing away from you, but your body is actually not moving. So your visual and body sensory has a conflict signal. I always feel motion sick when standing in the water when the water is retreating. So the same thing I think in VR or in XR, if your haptic, if your body, your muscle, your joint, right, does not sense you are moving, but your visual tell you are moving very fast, this will be the trigger for the motion sickness. One equipment we acquired a few years ago is a treadmill. I wonder if you watched the movie Ready Player One.
Yeah.
Right. So there's a
They have
treadmill.
it's like a flat surface, though. It's not like a traditional exercise treadmill. It's like built into the floor, and it can go in any direction, kind of a thing. So you can run sideways, and it's really interesting. Yeah.
The version we got is cheaper because I can't afford the large one. So this is omnidirection treadmill. So basically, it's like a dish, and you wear the special shoe. In the shoe, there's a small sensor can detect your step, right? How fast you move, right? So instead of using a motion controller or joystick to fly, to move, we ask people to move physically using our leg and muscle. I think that will actually prevent a lot of motion sickness because you take effort, just like the real world. You have to take effort to move.
Yeah.
There's a lot of actually video game has been developed based on this kind of setting, like zombie chasing you. You have to run away. It's a really good way to work out. Everybody is kind of sweating, and you got a full motion, visual, acoustic. Even with some like a 3D gloves, you can sense the friction and temperature change. Right. So I think more and more layers of sensory input is added into VR. I would say the most difficult one to add in is the taste. That part, I don't see anytime soon we're going to have it in VR. Because if you think about taste, is you take some compound into your body system, which is really dangerous if you have no idea what it is, right?
Right.
To simulate taste of flower or taste of, vanilla. So I think besides taste, other sensories like haptic actually can be simulated with a vest. You can feel the sensation from gentle touch to a punch, or even in some extreme condition, you can feel the bullet hit you, which is a very strong punch.
So we haven't really touched on AR and extended reality, and we don't have a lot of time to get into those, but obviously taking away that complete disconnection from the analog world into the digital world, augmented reality is overlaying information onto glasses. And you did mention that like the Meta headset and the Apple Vision Pro both have like this pass-through, so they act as a mixed reality device. But where do you see augmented reality going and the value in it? Because what I've been hearing is that a lot of companies feel like the augmented reality market is a much bigger potential even than virtual reality.
Right. If you know, like Microsoft HoloLens, right, which is one of the best product for augmented reality. You can also argue this is a mixed reality, but they are actually not using the same technology as Apple Vision Pro or Meta. This is actually a true hologram renderings through the glasses. And we have HoloLens in the lab. I think this is a tremendous value for people on site. So for example, construction industry, right? If you wear the HoloLens on site, you are able to see digital, ductwork, pipes overlaid on top of the physical reality. So know exactly where the point, right, you should put the joints in. In the manufacturing field, this is also very huge. For example, if you want to diagnose a jet engine, right, instead of create a virtual engine, you actually have a real engine right there. With the augmented reality, you are able to overlay the properties of color paint, right, the components. You can also have a communication with a remote coach who is able to give you advice what to do. In the medical field, this is also a very huge potential. For surgeries, with AR, you are able to actually highlight, right, the area you probably want to cut into. So I see AR has a huge benefit. And I don't think we are digitizing everything of the reality into VR. A lot of, nuance or the complexity of the real world is very difficult to reconstruct 100%, right, in VR. So why not you just overlay the data you want that you have both, analog and digital at the same time?
It does seem like it could be really, really useful on a day-to-day basis. Whereas VR, you have to get in the right mindset. You have to be in the right place. You got to have the goggles and put them on and load up the thing. It seems like with AR, at least maybe near future, within the next 5 years, you're putting on a pair of, we see this now from Meta, right, with the Ray-Ban partnership they have with the glasses, right? And you just put these on and you're getting additional information for the context that you're in whenever you need it. And that could be, I think that's why these tech companies are seeing such a potential value there for customers.
Yeah, this is more like a minority report. You have this, data everywhere. They are not necessarily, delivered through a virtual reality, but is, showed up on the different surfaces, on the different objects. It depends on who you are. And most importantly, I think it will maintain human-to-human interactions. One big problem we have in VR is you are not able to see another person. Even though that person you can render as avatar, even though we can do facial, motion capture to create a virtual avatar has some kind of expressions, but still is far away from simulate a real person perfectly. So maybe heard about uncanny valley, right? If you're trying to do a robot, looks like human, but you are 80% there, it just looks creepy.
Yeah.
So in VR, this is a huge problem. For anyone want to create like a talking avatar, you either go to the Disney style, nobody gonna complain. Or if you want to push into the high fidelity, you want to be very careful. So what I see in the AR is you still have this transparent interface. We are still able to see each other, right? So the facial communication, the body language is all preserved. What is different is in between us, we see a virtual object. Maybe it's a small scale building. So both of us can see the building, we can break apart, we can iterate. I think that is the really nuance of AR or MR over, virtual reality.
There's so many things that we didn't get to cover today. I mean, some of the things that I think are still interesting that is the ability for multiple people to be in spaces at the same time in virtual reality, and having, that model that they're all standing around as one example and talking about it and jumping in and exploring it, and at all different scales. I mean, you talked about the sphere, which one of the most impactful experiences I had in the movie that I saw in the sphere was, at one moment I'm riding in a taxi cab and the roof of the taxi cab feels like it's right there. And then we go into a cathedral and the ceiling is way up there, and I didn't change my physical environment, but the perception of it shifted so dramatically for me. And thinking about that from a storytelling point of view, as a designer of space, there's so much potential there, right? The other things that come to mind are persistence in digital virtual environments, right? Where we can all go in there and we can build a Tinker Toy set, and then we can leave, and then we can come back and it's still there. Where the paradigms of physical reality are shifting because of the potential that these technologies have unlocked. And to your point earlier with students, and I think about what video games and what movies have kind of brought to the space as far as inspiration is really, really interesting. And maybe the place where we leave this off is when people want to spend more time in these digital environments than physical environments, because they can be so, I don't know, they can be giving you a lot of dopamine on some level, but also maybe it's the only place you can retreat to, right? For another example, with that meditation example, because you live in a very noisy, busy place. So it's kind of, open-ended question there, but I feel like this is one of those things where there is so much potential in these, because we're engaging the senses in new and different ways, and the technology has grown so much over the last few decades that it's got to be a really exciting place for you to be practicing your craft and teaching students where they might take this in the future.
Yeah, absolutely. I love, because I'm an architect, I love any content related to space and time. Mm-hmm. I think this is probably fundamentally for everybody, from quantum physics, right, to astronomy. I like any content, either is automation from AI or human modeled, allow you to be immersed and embodied in that environment. And there is a value you can get, or experience you can get, will help you to be a better person. Either that is meditation, or it could be a storytelling. Mm-hmm. We find it's very powerful, especially for, tell the stories or narrative through VR compared to a film or book. There's some research projects about, reconstruct the concentration camp, World War II, and then allow people to immerse in. And other, examples like travel back in time. We are doing like a historic city of Avondale, which is a neighborhood in Cincinnati. We're creating this city based on 1950s, so people can see what the city looks like. The information we have is relatively limited. It's like a black and white photo, some aerial photos. Then we use a lot of automation, especially using generative AI to reconstruct the color, to predict the material, to predict 3D model. Then we formulate this in a kind of 3D virtual Avondale neighborhood in 1950s. Then you can see all the missing buildings. We lost a lot of buildings during the urban renewal. But now in the virtual building, virtual scenario, you see this old storefront. It's a pretty amazing experience. You can allow people have this kind of lost memory, or tell the story, give a narrative. I think for anyone who has watched any 360 video on YouTube, you will understand the experience you gain from that immersiveness is far beyond just reading a book. There's another video on YouTube, is a Titanic. I would highly recommend everybody to watch. You are able to see the whole, tragedy of Titanic, thinking you are one person on the deck immersively. You have to make decisions.
So that's a 360-degree video. So if you're wearing one of these headsets, you can watch that movie, and you're locked to wherever the camera is, I assume, because it's a movie, but you can look around. You can look wherever you want to look around, yeah.
Yes. You can also see the struggle and decision-making people have to make in that extreme condition. If this can be designed as a video game, I think it should allow user to make decisions. Then you are fully engaged into the storytelling.
Amazing possibilities here, Ming. This has been a fascinating conversation. Thank you so much for hanging out with us and sharing your passion with us today. Appreciate it.
Thank you, Ming.
Great pleasure to talk with both of you.